Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. First of all, a very happy new year to all the viewers, and from this new year we are going to start a brand new topic called assignment model. So in assignment model, each facility has been associated with one and only one job, or we can say that each job is associated with one and only one facility. And assignment model is also considered as an extremely degenerated form of transportation problem. So suddenly the question pops up into the mind that when we already have a proper method for solving transportation problem, why there is a need of an assignment problem? So we will see into all these factors. So let us see. Here we can see that the cost matrix has been given, where there are n number of facilities and there are n number of jobs. So the first prerequisite for an assignment model is to have a n cross n matrix. Okay, in transportation model we have n cross m matrix, and in assignment model we need to require n cross n matrix. So why is it so? As we say that each facility has been associated with one and only one job. That means facility 1 can be associated with any of this job, any one job. So the supply here is 1. Similarly, each job can be associated with one and only one facility. That means job 1 can be assigned to facility 1 or 2 or 3 or n. So here the demand also is 1. So in transportation model we have seen that the total supply has to be equal to total demand. So as we can see here, the supply here is 1 for all the rows and the demand here is 1 for all the column. Now to balance the supply and demand, it has to be a square matrix to balance the total supply equal to total demand. That's why the first prerequisite for solving assignment problem is that the matrix should be a square matrix or n cross n matrix. Now as we know here that Cij is the cost of assigning facility I to job j. That means C11, C12 are the cost that is for assigning job facility I to job j. Suppose C2, cost C2 is associated with assigning facility 1 to job 2. Similarly, we can see that Xij is the number of units assigned of facility I to job j. So here we have x11, x12 up to x1n, similarly x21, x22 up to x2n, and xn1, xn2 up to xnn. So we can see here that there are n into n, that means n square number of decision variables. So if we count all of them, it will be n square. So n square is the number of decision variables in this problem, and there are 2n number of constraints. So we will see how the constraints are 2n, and n is the number of assignment. So if we assign for each facility and each job, for an optimum assignment we need to have total n number of assignments. And as we move further, the mathematical representation of this can be shown as, our objective is to minimize z. Minimize z is equals to summation of Cij Xij, where I is equals to 1 to n, j is equals to 1 to n. Now the constraints are, these are subjected to constraints. Constraints are summation of Xij for I equal to 1 to n is equal to 1. Similarly, summation of Xij from j equal to 1 to n is equal to 1, and Xij can be either 0 or 1. Now this mathematical form is very similar to the one we have done for the transportation problem, and let us see what are the differences here. So the minimization function is same, that means the cost multiplied by number of units. Now as we can see here that we have already said that for assignment model there should be only one job for one facility or one facility for one job. That means that if we assign this particular cell, that means facility 1 is assigned to do job 2. Once this is assigned, that means the value of xij will be equal to 1. Okay, if the facility is I is assigned to job j. So here I am assuming that if I assign this particular cell, then facility 1 is assigned to job 2, and for this particular cell the value of xij, that means x12 will be equal to 1. So if this is 1, then the supply is satisfied and the demand also satisfied. That means no more assignment can be done in this row. Similarly, no more assignment can be done in this row. So the xij value for the other cells in this row is equal to 0. This is what is written here, xij is equal to 0 if the facility I is not assigned to job j. So we know that we have assigned here and the rest of the cell in this row are not assigned. That means the value of xij in all these cells is 0. Similarly, once job 2 is assigned to facility 1, no more assignment can be done in this column and the value of x22 up to xn2 will be equal to 0 because the demand has been fulfilled. So what we can see from here that the constraint we have seen, summation of xij for I equal to 1 to n, that means keeping the j constant. That means if this is constant for job 1, if it is assigned to any one of the cell, the value of the cell will be equal to 0, or the allocation in the other cell will be equal to 0, and if we sum it all, this is equal to 1. Similarly, we can have n number of constraint here. Okay, so and the second constraint says that xij equal to 1 for j equal to 1 to n. So for j equal to 1 to n, I is constant. That means if facility I is constant and j is changing from 1 to n, it can be assigned to any one of these cells. So if it is assigned here, then the values in the other cell is equal to 0. That means if we sum all of these values, it will be equal to 1. So this is what we have written here. So for n number of facilities, again we have n number of constraint. So n number of constraint plus here n number of constraint, the total constraints we are having is 2n. Okay, and as we have discussed that xij can be equal to 0 or 1. So xij is the quantity we assign. So the cell in which we are assigning, the value of xij will be 1, and for the remaining cell in that row or in that column will be equal to 0. So this is clear. And one more thing is that we need to understand why we use assignment model rather than using transportation model. So we know that whenever we are assigning here in the assignment matrix, it will cross out one row as well as one column, and whenever we are fulfilling supply and demand on the same allocation in transportation problem, we know that it causes degeneracy. So here every time we allocate in any cell, it will have fulfilled the supply as well as demand, which leads to degeneracy. And in transportation model, we know that we must have m plus n minus 1 number of independent allocation. So as for this matrix, the maximum or the number of independent allocation can be n plus n minus 1. That means 2n minus 1 is the number of independent allocations, and we know that the number of assignment we can have is only n. So if we subtract this, we have n minus 1 empty places or potential cells in this matrix which can have an independent allocation. So this makes the problem very degenerate, and which cause the calculation to go a long way. So in order to reduce that, we have made a new method which is called assignment method. And now let us understand what are the properties of an optimal solution in assignment. So we need to remember these two properties on which our assignment model works. So the first property is that if Cij is greater than equal to 0, the solution is optimal with z equal to 0. That means Cij is the cost matrix, cost coefficient. So if the cost coefficient is greater than or equal to 0, then the optimal solution with z equal to 0, or we can say that the solution with z equal to 0 is optimal. So as we know that the value of z is the summation of all the assignment cell values. That means if there are number of cell assigned, we need to add all the cost coefficient of those cells, and if those cells are having the value 0, then we can say that our solution is optimal, because Cij cannot be negative. So this is very simple to understand, that for Cij greater than equal to 0, the minimum value of z one could get is z equal to 0, and for obtaining z equal to 0, we need to have all the assigned values as 0. Okay, because when we are assigning the value 0, then only it will add up to 0, or if it has a certain positive value, it will not be equal to 0. So let us see the second property here. If all the elements of the row or a column is increased or decreased by the same constant, the optimal solution does not change, only the value of the objective function changes. So this is a very important property. So what this says it is that if the row or a column, suppose when a row is increased by the same value, that means if I increase this cost coefficient by same value, that is plus 2 plus 2 plus 2 plus 2 plus 2 up to n, then what will happen is my solution or optimal solution is not going to change. The only value going to change is the value of objective function, that is the value of z. Similarly, if I decrease the same value in each cell in this row, then also the optimal solution is not going to change. The only thing going to change is the value of objective function, that is the value of z. So after understanding these two properties, we can easily solve the assignment model. So let us see what methods do we follow to solve the assignment model. In assignment method, we use the Hungarian method to solve this problem. So let us see the basic steps we need to assign the assignment problem. So first is to prepare a square matrix. So as we have discussed that to solve the assignment problem, it has to be a square matrix, and if it is not a square matrix, then we need to add a dummy row or a dummy column to make it a square matrix with cost coefficient 0. We'll take cost coefficient 0 for minimization problem. Okay, so and the second is to reduce the matrix. So reduce the matrix means that if we have certain matrix as we have considered in this problem, we need to reduce that matrix and we need to make at least one value in each row and in each column as 0. So what it will do is it will help us assign those values, and if we assign all the zeros, then our value of z will sum as 0. So we can see that how can we reduce the matrix. We can reduce the matrix in two steps. First is to have row reduction, and the second is to have column reduction. Now in the row reduction, we can see that we need to have at least 1 0 in each row, and we must ensure that the value of Cij, that means cost coefficient, should remain positive, as we have discussed here. So what we will do is we will select the minimum value from each row. We will select the minimum value from each row, and we will subtract these values by all the values in the cell. So for for row 1, the minimum value is 13, so I have written 13. Here the minimum value is 11, I have written 11. Here the minimum value is 10, so this is 10. Here the minimum value is 14. So now we will see that we will subtract all these values by 13. Similarly, we will subtract all these values by 11 and so on. So let us see after solving what we get. This is 15 minus 3. 15 minus 13 is 2. 13 minus 13 is 0. 14 minus 13 is 1. 17 minus 13 is 4. Similarly here 11 minus 11 is 0. 12 minus 11 is 1. 15 minus 11 is 4. 13 minus 11 is 2. Similarly 13 minus 10 is 3. 12 minus 10 is 2. 10 minus 10 is 0. 11 minus 10 is 1. And in the last row 15 minus 14 is 1. 17 minus 14 is 3. 14 minus 14 is 0. 16 minus 14 is 2. Now we need to see that whether we have zeros in each row and in each column or not. So as we have seen that each row is having the value 0. Row 1, row 2, row 3, row 4, each is having the value 0. And in column, if we see, column 1 is having 0, column 2 is having 0, column 3 is having 2 values as 0, and column 4 is not having any value as 0. So after row reduction, this is the row reduction we have done. If we are not getting the zeros in each row and in each column, we need to apply column reduction as well. So now we will apply column reduction. Now we will select the minimum value in the column and we will subtract all the other cells by those values. So in column 1, column 2, column 3, the minimum value is 0. So if 0 is subtracted from all these, the value is not going to change. In the fourth column, we can see that the minimum value here is 1, and if we subtract value 1 from each of the value, these are going to change. Okay, so this will become 3. Okay, this will be 3. This will be 1. This is 1. This is 1 minus 1, 0. And this is 2 minus 1, 1. Now as we can see that we have completed the step 2, that means we have reduced the matrix and we now have zeros in each row and in each column. And after this we have to make assignment. Now how do we have to make assignment? We need to assign first row wise, then we will move column wise. So in row wise assignment, we need to see that if there is an assignable 0, and what is assignable 0? If there is single 0 in this row, we can say that this is assignable 0. If there are more than one 0, then we will skip this row and move on to the next row and see if there is a possible chance of assignment or not. So basically what we are going to do, if there is a single 0 which is eligible for assignment, we are going to assign it, and if it has more than one 0, then we will leave it as it is and move to the next row or next column. So let us start assigning. When we move from row 1, we can see that this is a single 0 here. That means we can assign this, and once this has been assigned, that means no more assignment can be done in this row and no more assignment can be done in this column. Okay, just as we have discussed previously. So moving on to the second row has only single 0, so this can be assigned. So this is assigned. Now after assigning this means that no assignment can be done in this column and no assignment can be done in this row. Now moving on to the row 3, we see that we have two assignable zeros. So we will leave this row 3 as it is and move to the next row. So after moving to row 4, we can see that in row 4 we have single 0. So we will assign this. And after assigning this, we can see that no more assignment can be done in this column and no more assignment can be done in this row, and no more assignment can be done in this column. So in this column we can see that here is 1 0, but once this has been assigned, no more assignment can be done in this column. So this 0 is become ineligible for assignment. Now once we have completed assignment row wise, we will see column wise. When we see column wise, we see that there is already assignment, then move towards second, there is already assignment, move towards third, we have already assignment, move towards fourth column. In fourth column we can see that we have only 1 0, that means we can assign here, and after assigning here, no more assignment can be done in this row and in this column. And now after completing our assignment, if the number of assignment is equal to the order of matrix, that means it is 4 cross 4 matrix. So if we have 4 number of assignment, then our solution is optimal. So here we can see that all the 4 assignments can be made. Okay, and we need to calculate the value of z here. Okay, so for this particular matrix, if I'll add all the values of 0, 0 plus 0 plus 0 plus 0, what we will get as the value of z equal to 0, which has come from this particular property. Now from the second property, we know that after reducing the matrix, the optimal solution does not change, only the value of objective function change. That means this particular solution is also optimal for this matrix, but the only thing is the value of objective function changes. So that means this is optimal for this matrix also. And to find out the value of z minimum here, z minimum, we will see the values in the original coefficient matrix, original cost coefficient matrix. So here we can see that value is 13, so this is 13. Here the value is 11, so 13 plus 11. Here the value is 11, again plus 11. Here the value is 14, so plus 14. And after adding all this, this will be 22, 35, 39, 49. This will become 49. So the minimum value of z we can obtain by assigning this is 49, and the assignment, or we can say that optimal assignment is facility 1 has been assigned to job 2, facility 1 has been assigned to job 2, facility 2 has been assigned to job 1, facility 2 has been assigned to job 1, facility 3 has been assigned to job 4, facility 3 has been assigned to job 4, and facility 4 has been assigned to job 3. Facility 4 has been assigned to job 3. So this is our optimal assignment, and it is same, or we can say that this is optimal for this matrix as well as this matrix. Okay, so what actually we have done here is we have made these values 0. Okay, came to 0, and we will try to allocate the values. We have tried to assign the values 0, and after assigning all the values, we can see that in the original matrix their values are given, and by adding those values we are getting the value of objective function, which is the minimum value of z we can get. Okay, and there is one more confusion. We can say that when we are assigning the values of 0 here, and we are saying that for these particular assigned cells the value of xij is equal to 1. So both these things are different, because we are assigning when the cost coefficient becomes 0. Here we are assigning when the cost coefficient are becoming 0, and after assigning this the quantity we assigned is equal to 1, which is xij equal to 1, and the remaining values in this column is xij equal to 0. So we need to understand the difference. So just now we have seen how to make an assignment, and if we could not get an optimal assignment here, we will see what we can do in the coming lecture. So I hope you like the lecture. If you like lecture, please share the lecture. Have a nice day. Thank you.